Good afternoon or good evening to Dr. Joshua. So today I'm going to present about some topic in Chapter 5 Bond Valuation and Chapter 6 Stocks and Money Market Instruments. So I will start off with Chapter 5, which is the bond valuation. Before I go into the topic, I would like to give some brief introduction about what is bond. A bond is an interest-bearing security which promises to pay a stated amount of money at some maturity date. A bond can be considered as an agreement between an investor and a company or government. So in this case, the government or the company becomes the borrower or the issuer, while the investor who lend the money to the issuer become the issuer's creditors through the bonds that they hold. In real life, there are many types of bonds, such as treasury bonds, municipal bonds, mortgage bonds, and so on. But in TOI, we are mainly focused on bonds with coupons. They have a periodic payment of interest made by the issuer, and the bond includes attached coupons and pay periodically, usually annually or semi-annually, interest payment during its lifetime. And under bonds with coupon, we have something special called a zero coupon bond. These bonds do not pay any interest and it just pay a lump sum of value at the redemption date. Before we derive the pricing formula for bonds, we have to know some basic notations used in bond valuation. So under of this, all of these are the basic notation we use in bond valuation. First one, P, which is the price of the bond. F, which is the par value or the face value. C is the redemption value of the bond. R is the effective coupon rate. The product of F and R is the amount of coupon payment. I is the yield to maturity, and the last one, N, is the number of coupon payment periods. As we know that the bond has a periodic coupon payment annually and a redemption value at the end of maturity date. So before we came up with a pricing formula for bonds, we can construct a timeline in order to visualize the payment better. Therefore, from the timeline, we can derive the basic pricing formula for bonds. So the first pricing formula for bond is the basic formula, which is P equals to FR, the coupon, times with the annuity AN plus CVN. And the second formula, which is the premium discount formula, is derived from the first formula, while substituting Vn to 1 minus IAN, and then we will get P equals to C plus FR minus CIAN. Bonds can be priced at premium, discount, or at par. When P is more than C, which means that the price is more than the redemption value, the bond is sold at premium. The difference between P minus C is known as premium. This happens when the coupon rate is more than the yield to maturity. On the other hand, when P is less than C, the bond is sold at discount. The difference between C minus P is known as discount. This happens when the R is less than I. So below are the verification whether the bond is premium or the bond is discount. For case A, when R is more than I found out that the P is more than C, which means the bond is in premium. And then for case B, when the R is less than I found out that the P is less than C, which means the bond is at discount. Moving on, I'm going to talk about callable bonds. A callable bond, also known as a redeemable bond. It is a bond that the issuer may redeem the bond before it reaches the stated maturity date. A callable bond usually has a call date which is specified by the bond issuer. There is some relationship between callable bond with premium or discount bond. The first one, if the bond was sold at premium, the call date will most likely to be the earliest date possible. The second case, if the bond was sold at a discount, the call date will be the most likely be at the latest date possible. So now I will proceed with my first tutorial question. I have summarized the question into a table. In this question, there are three bonds, which is bond 1, bond 2, and bond 3. Each of them has different coupon payment, which is 40, 30, and 80 respectively. but three of them have the same redemption value, maturity period, and yield rate. And we label the price of the bond as PQR for bond 1, bond 2, and bond 3. So in this question, we have to prove that R is equals to 5P minus 4Q. By using the pricing formula, which is the C plus FR minus CIAN at the table just now, we can solve this question. For bond 1, we can substitute all the value into the formula and get this equation and label as equation 1. For same goes to bond 2, we will get this equation and then label as equation 2. Then we take 1 minus 2, we'll get P minus Q equals to 10 AN. Then we make AN into the subject, which then we will get P minus Q over 10. Next, we can find the price formula for bond 3 and we will get C plus 80 minus CIAN. Then we can split this 80 into 50 plus 30 to obtain 50 AN. For the AN, we can substitute with P minus Q over 10 and the remaining this term, we can substitute from here, which is Q minus C. After some simplification, we will get R is equals to 5P minus 4Q. Moving on to the second question, a 100 par value bond with 5% semi-annual coupons. Semi-annual coupons, so the R will be 2.5%. It's callable at the following times. These three are the redemption value, 108 for 5 to 9 years. But we will change the 5 to 9 to 10 to 18 later on because this is semi-annual coupons. And the same goes to 103.5 and 100. The question asks us, what is the price should an investor pay for the callable bond if they wish to realize a yield rate of 6% payable semi-annually, which means I is equals to 3%, B 4% payable semi-annually, which means I is equals to 2%. So for case A, when I is equals to 3%, the R is less than I because R is only 2.5%, the bond is sold at discount. Therefore, the issuer can call back the bond at the latest possible date. So we can compare the result by choosing n equals to 18 from the time frame 10 to 18, n equals to 28 from 20 to 28, and n equals to 30. So by using the basic formula, which is this one, we can get the price of the bond. So when n equals to 18, C equals to 108, we can substitute all the value inside the formula and we will get 97.82. The same goes to n equals to 28, C equals to 103.5, we will get 92.15. And last one, n equals to 30, C equals to 100, we will get 90.20. So the investor should pay 90.20 because when n equals to 30, the price is the lowest among these three. So for case B, when I is equals to 2%, R is more than I because now R is 2.5% is greater than 2%. The bond is sold at premium. Therefore, the issuer will call back the bond at the earliest possible date. So using the same method, we compare the result by choosing n equals to 10 for 10 to 18 because this is the earliest, and n equals to 20, n equals to 30. So by using the formula and substitute all the value, we will get the price of the bond. So when n equals to 10, C equals to 108, we'll get 111.05. N equals to 20, C equals to 103.5, we'll get 110.53. N equals to 30, C equals to 100, we'll get 112.20. So the investor should pay 110.53 because when n equals to 20, the price is the lowest among these three. Moving on to the third question. So the first call date of a callable 100 par value 5% bond with annual coupon is the date immediate after the 10 coupon payment with C is given by this piecewise function. And the question asks us, what is the price should an investor pay for the callable bond if she realizes a yield rate of 4% payable annually? So in this case, I is equal to 4%. And R is more than I because R is 5%, which is more than 4%. The bond is sold at premium. So the investor will call back the bond at the earliest possible date, which is n equals to 10. Then we substitute n equals to 10, C equals to 100, F equals to 100, R equals to 5% inside this formula and we will get 108.11. And then for n equals to 18, 19, and 20, we cannot just choosing the n equals to 18 because the redemption value for three of these are different. So after I calculated, when n equals to 18, c equals to 90, and then the value we get is 107.72. And when n equals to 19, c equals to 60, we will get 94.15. And lastly, n equals to 20, c equals to 10, we will get 72.52. So in conclusion, the investor should pay for 72.52, which is the lowest price among these four prices. So for now, I'll be covering some topics in chapter 6. Before I go into my topic, I'll be giving some brief introduction about what is stock. Stock is a kind of securities like bond. A stock is also known as equity. It's a security that represents the ownership of a fraction of a corporation. Stocks are also called as shares. Companies usually sell stocks and shares to raise the funds to operate their business well. There are two main types of stock, which is the preference stock and the common stocks. So as I mentioned just now, there are two types of stocks. One is preferred stocks and one is common stock. So in this slide, it's all about the key features and characteristics of the preferred stock and a common stock. A preferred stockholder usually has no voting rights, and preferred stock has no maturity date, which means that this is the perpetuity. And preferred stock give a fixed rate of return, which is a fixed dividend rate to the preferred stockholder. And preferred stockholder will get the dividend before the common stockholder. And for common stockholder usually has voting rights and whole ownership. And same as the preferred stock, common stock has no maturity date, which is also a perpetuity. And the interest varies, so the dividend doesn't fix. Therefore, it is higher risk because the dividend depends on the company's earning. So now I'm going to show you how to find the price of stock. I'll start off with preferred stock. Preferred stock has fixed dividend payment D with interest I, and it is a perpetuity. So we can draw this timeline and write P equals to dV plus dV squared plus dV cubed plus until infinity. Then we factorize D out, we'll get this term. This we can use sum of infinity to find the sum for all the dividend payment. Then we substitute 1 over 1 plus I into V, and eventually we'll get P equals to D over I. And for common stock, we know that the dividend change time to time. So we assume that the next dividend payment D follow a geometric progression with common ratio 1 plus K with the interest I. So similarly, we can find the price of stock using the present value of all of these value. And then eventually, after some simplification, we'll get P equals to D over I minus K. So for now, I'm going to moving on to my fourth tutorial question. For this question, this is common stock, and the dividend is RM2 because it states that 50% of its earning will be earned as dividends. So RM4 times 50% which is RM2, and we assume the earning of the corporation increase 5% per year indefinitely. So K is 0.05. So the question wants us to find the price of the stock when the interest is 10%, 8%, and 6%. So from previous slide, we said that the price of common stock is D over I minus K, which equals to 2 over I minus 0.05 in this case. So to find the price of the stock, for A, when the interest is 10%, we will substitute 0.1 into this, and then we'll get RM40. For B, 8%, we'll get 66.6667. For C, which is 6%, we substitute 0.06, and eventually we'll get 200. So now I'm going to present my last question. This is also a common stock question which currently earning RM8, and the dividend is RM4 because 50% of its earning will be earned as dividend. And we assume that the earnings of the corporation increase at the rate of 6% for the first 10 years, 3% for the second 10 years, and 0% thereafter. So for this case, we cannot straight away apply the common stock formula because the growth rate for the first 10 years, second 10 years, and the remaining years are different. And we have to find the price of the stock when the I is equals to 12%. So in this case, we are going to divide the equation into three parts, so it is easier to solve. At first, we write the sum of the first 10 term plus the sum of the second 10 term plus the sum of the remaining terms. So for the sum of the first 10 term and the sum of second 10 term, we can use the sum of the first n term from geometric progression. The formula is here. And for the remaining sum of the remaining terms, we can use sum of the infinity. Then we substitute all the correct value into the formula. Eventually we will get 51.08 for the price of stock. That's the end of my presentation. Thank you and have a nice day.